Okay, more problem-solving examples, and this is really just a basic approach to what's used commonly when you have to do conversions in problem-solving, which many problem-solving problems are all done just doing this basic kinds of conversion. Some are done with ratios and proportions, which we just demonstrated in the last video, but a lot of problems are done by using conversions, and you'll see in the future as we do those. So, let's get to it. When we do dimensional analysis, we set up unit ratios with the units aligned diagonally so they will reduce in a multiplication. So note the difference. When we did problem solving with ratios and proportions, we had one ratio equal to another ratio. A dollars to B gallons is equal to C dollars over X gallons. Now we're going to take something like 2,500 psi, which means pounds. This means pounds per square inch. That's LB. This is square, and this stands for inch. So that's pounds per square inch is what that really stands for, to tons per square foot. So, there's supposed to be a zero there. So this is 25,000 pounds, all right, LB, per square inch. And when you have a rate like this, a square inch is 1 inch by 1 inch. 1 inch by 1 inch. It's not the same as an inch because it's a unit of area. So when we have 25 pounds and we want it per square inch, we write that pounds over square inches for pounds per square inch. So we want our answer to be in tons per square foot. So we want in the numerator of our answer, we want that to be tons in the numerator and square feet in the denominator. This is a little abbreviation for square feet to put that little exponent of 2 up there. So how do we convert pounds per square inch to tons per square foot? Well, in order to convert pounds to tons, we need to know that unit ratio conversion. That is, we need to know that 2,000 pounds is equal to 1 ton. So that, if we're going to convert pounds to tons, we'll have to have pounds. Notice it says they have to be aligned diagonally. So we'll put pounds here. To get rid of pounds, you'll need that in the denominator, so those will reduce. And we need to get tons up here. Now, I always set up unit ratio conversions by putting the units in first. And then I worry about where the numbers go. So I know 1 is the number of tons and 2,000 is the number of pounds. I use that strategy because the most important thing about setting up a unit ratio is making sure your units are set up properly. And if you're converting with a multiplication, they have to be diagonal. Now remember, that's different than when you use a proportion when they're equal, dollars to gallons and dollars to gallons. Here, we're multiplying. They're not equivalent. We're converting pounds to tons. And now also, we have square feet we want in the denominator, and now currently we have square inches. So in order to convert the square inches in the denominator to square feet in the denominator, we need these square inches to reduce with square inches up here. So we put square inches here, and down here we'll need square feet. Now we do need to know how many square inches are in a square foot. I'm sure you're all familiar that 1 foot is equal to 12 inches. Well, that's not the same as a square foot. 1 square foot means we have a foot by a foot. That's what a square foot is. I'll abbreviate that SQ feet. 12 would be 12 inches by 12 inches, so we square the 12 to get square inches. So that would be 12 times 12, which is 144 square inches, because a foot is 1 foot by 1 foot, and the total area would be 144 square inches. So we have 144 square inches there is 1 square foot. Now notice our pounds we're going to reduce here, and our square inches is going to reduce here. They're diagonal. And this is all multiplication, as you can see. So that will give us what unit in the numerator? Tons up here and square feet in the denominator. That gives us this rate that we were asked to find, tons per square foot. So I'll just do that on my calculator. I can multiply everything in the numerator, be 25,000 times 1 times 144. So I'll do that. Oops, yeah, 25,000 times 144. Now the denominator is clearly 2,000. And so 25,000 times 144. That'll take a second here. My calculator's warming up. So 25,000 times 144. That is 3,600,000. There's 5 zeros there. 3,600,000. And so if we divide that by the 2,000 now, by the way, we could have reduced these 3 zeros and those 3 zeros and made it a lot easier and just gone 25 times 144 divided by 2. That would have given us 3,600 divided by 2. We could do it here also. But that gives us 1,800 tons per square feet. So that's 1,800 tons per square feet. That is pretty heavy. That's a lot of weight in a square foot. Well, 25,000 is a lot of pounds in a single square inch. Okay, let's look at the next problem. Now this is a little different. It says, consider driving in an area of Canada where the speed limit is 100 kilometers per hour. That's abbreviated kph. And you have a vehicle that only reads out in miles per hour. So if your speedometer is accurate and it displays 70 miles per hour, how much will you be fined if you are ticketed at that speed and the fine for speeding is $9 Canadian dollars per kilometer per hour over the limit? So first of all, if you're driving at 70 miles per hour, is that actually faster than or slower than 100 kilometers per hour? Are you going to get fined at all? So we need to be able to convert 70 miles per hour, and this is a rate, that P means per in this case, miles, 70 miles per 1 hour, and we want that to be actually kilometers per 1 hour, right? Well, the denominator in this case is already 1 hour. We don't have to convert that like we did in the previous problem where we had square inches that needed to be converted to square feet. So this is going to be easier, at least for this part of the problem. So what we do need to be able to do is know how we want to get rid of miles down here and get kilometers. So we have to put miles in this diagonal, put kilometers up here, and now you need to know that conversion. Now, you won't have to memorize that. The units for metric you need to know yourself. You can write that down on your 8.5 by 11 note sheet. But if you had to do this problem, I would give you a note. I would say, okay, 1 kilometer is equal to approximately 0.62 miles. So I'll give you that. So we'll put the 0.62 for the miles and 1 kilometer. So this would be given in a problem like this. You don't have to remember all those or write them down. So if we do this, the miles will be reduced, right? This is a multiplication. Miles are reduced, and we'll get kilometers. So let's look at that number. That's going to be 70 divided by 0.62. That's 112.9. I'm going to say it's about 113. If you got an American license plate, they're probably going to charge you rounded up in Canada. So anyway, that's 113 kilometers per hour. Well, that does exceed the 100 kilometer per hour limit by how much? That's 13 kilometers per hour over the limit. Now you pay 9 Canadian dollars per kph. That means it's going to cost, if you multiply that, we'll multiply $9, I'll put Canadian down there, they're not quite as much as an American dollar, per 1 kilometer per hour over. So your 13 over is 13 times 9, and 13 times 9 is 117, and those are Canadian dollars. That's probably close to about $100 US. Depends on when that happens, the conversion factor at the time. Okay, let's do another one that requires some converting. It says a certain pesticide is sold in 10-pound bags, which cost $65 per bag, and it will cover 50 acres. How much will it cost, so we're looking for dollars, how many dollars will it be to buy enough pesticide to cover a field that is 16,000 feet by 16,000 feet? Wow, well that's a big field, 16,000 by 16,000. Now, feet is just a unit of length, but when we have 16,000 feet by 16,000 feet, we presume that's like a square field. It's like over 3 miles each side, so this is probably in Texas. So 16,000 feet by 16,000 feet, that's a lot of acres. And we need to know, we know that it costs $65 for a 10-pound bag to cover 50 acres. So we know this fact, that we know how many dollars it costs to cover 50 acres. So if we know how much it costs for 50 acres, it would be nice to know how many acres this is. So the acres is an area measurement. And I would give you this fact: 1 acre is equal to 43,560 square feet. And notice this is feet by feet. How do you get square feet? You multiply that to find that area. So we will take 16,000 as basically one length, and the width is the same, so it's a square. 16 times 16, it should be 256. And then, and there's how many zeros? That should be 256, but there's 1, 2, 3, 4, 5, 6 zeros. That's 256 million square feet, because this is feet by feet, which gives you square feet. Wow, so that's how many square feet we have. Now basically we're going to convert square feet to dollars by going through acres. So check it out. If there's 256 million square feet, if we want to get rid of square feet, we know that we can change that to acres by putting square feet in the denominator. That's 43,560, and 1 acre. That will convert it to acres, right? That gets rid of square feet. But also, you notice that to get dollars, it's $65 for 50 acres. So $65 for 50 acres will end up reducing out acres as well. So feet will reduce out and acres will reduce out, and you'll be left with just dollars. Now you could have just multiplied this first and found out how many acres there were. You could find out if it's $65 for 50 acres, you could divide that and find out that's like $1.30 per acre, so you could multiply by $1.30, but it all comes out the same. So, wow, I'm just going to take this. The feet will reduce, the acres will reduce, and I'll do this division first. Oh, yeah, I'll do this division first. 256 million divided by, I'm going to make sure I put the right number of zeros in, 1, 2, 3, 4, 5, 6, divided by 43,560. You always want to double check your calculation. Now that's 5,870, well it says 6.9, I'm going to say 77 approximately acres. And then it's $65 for 50 acres. So basically you could find out how many, this is acres, and acres of course would reduce. And so we take that 576, I wrote it here, but I'll keep that number in here. I'm going to times that by 65 and then divide by 50. And that is 7,640.03. So I'll just round off. That's about $7,640 of pesticide, which is a lot of money, but this is, granted, remember, that's almost 6,000 acres, so it's a pretty cheap cost for that. Okay, I'm going to pause this and start a new video for the last two.